So, let's go. Number 1, the moon is rusting. You grew up with one fact about the moon: it's gray, dead gray, museum gray, the color of a thing that stopped happening billions of years ago. And then a spacecraft looked closer and found red. Not lava red, rust red. The exact orange-brown stain you'd find on an old bike left out in the rain. India's Chandrayaan-1 probe, back in 2020, mapped the poles of the moon and spotted hematite. Hematite is iron that is rusted. And here's the part that shouldn't be possible. To make rust, you need iron and water and oxygen. The moon has iron. It has a little water. But oxygen? The moon has almost none. And worse, it's constantly blasted by the solar wind, a stream of hydrogen that should rip rust apart faster than it ever forms. So something is delivering oxygen to the moon. Something that overpowers the sun. And when scientists followed the trail, it led back to the last suspect anyone expected. You. For about 5 days every month, the moon slips behind the Earth and hides inside our planet's magnetic tail. In that window, the solar wind gets blocked. And instead, the moon gets bathed in something scientists literally call Earth wind. It's the top of our own atmosphere leaking. Oxygen atoms peeling off the Earth, drifting across 380,000 kilometers of empty black, and landing on the moon. Feel how strange that is. Every breath you've ever taken came from that same reservoir of air, and some of that air is escaping right now, sailing across space and slowly turning the moon to rust. The rust is worst on the near side, the side that faces us, the side pointed straight at the source, like it's catching the fallout of us just being here. It's stronger where the Earth-facing hemisphere drinks in the most of our leaking sky. NASA scientists said it plainly. This was surprising. They did not expect the moon to be capable of rusting at all, and they still can't fully close the case because rust is turning up in spots that don't have obvious water either, which means something else, maybe fast little dust impacts, is freeing up the ingredients too. So the dead gray rock isn't inert, it's reacting. It's being changed by its neighbor, one exhaled atom at a time. The moon has been catching your planet's breath for billions of years, and that's the gentlest thing hiding up there. Number 2, the buried metal under the far side. Turn the moon around. Look at the face you never see. On the far side sits the biggest wound in the entire solar system, the South Pole Aitken Basin, 2,500 kilometers across. So old and so deep that when something carved it, it nearly punched through the moon. That's the crater. That's not the mystery. The mystery is what's underneath it. When NASA flew a pair of probes called Grail around the moon, mapping its gravity with insane precision, they found something wrong under that basin. A lump. A concentration of mass so heavy it's physically dragging the floor of the basin down by about half a mile. And when they weighed it, the number came back at 2.18 quintillion kilograms. Say that number slowly. 2.18, followed by 18 zeros. A blob of extra dense material buried more than 300 kilometers deep, big enough to bend the gravity of an entire world. Nobody put it there on purpose. So what is it? The leading answer is almost worse than a mystery. Scientists think it might be the corpse of the thing that made the crater. When a metal asteroid the size of a small moon slammed into the far side, its iron-nickel core may not have splashed back out. It may have plunged in and gotten stuck, frozen in the moon's mantle before it could sink to the center. Which means the moon might be carrying the buried heart of another world inside it. A dead attacker, entombed under its own crater. The other explanation is stranger in a quieter way. Early in its life, the whole moon was an ocean of magma. As that ocean crystallized, the heaviest minerals could have sunk and pooled into a dense slug, a leftover from the moon's molten childhood still lurking down there. Here's what unsettles the scientists. That much mass, that deep, should have sunk further, or spread out, or vanished into the interior long ago. Instead, it's just hanging there, held up in the mantle like a marble suspended in honey, and the models don't fully agree on how. You look up at the moon and you see a calm gray disk. On the side turned away from you, half a mile of rock is being pulled down by a mass we can't identify, and it has been for 4 billion years. Something is down there. We just can't dig it up. Number 3, the mascons that drag spacecraft down. Here's a thing nobody tells you about the moon. Its gravity is lumpy, not smooth. Not the neat little pole you learned in school. It has bumps, invisible ones. And those bumps have killed spacecraft. They're called mascons, short for mass concentrations, and they're exactly what they sound like. Buried under the big dark seas on the moon's face are pockets of ultra-dense rock, and each one grabs at anything flying overhead a little harder than the ground around it. You can't see them. No camera catches them. A pilot would have no warning. But an orbiting spacecraft feels every single one. Fly over a mascon, and the moon reaches up and tugs you down. Just slightly. Then you pass, and it lets go, and the next one grabs you somewhere else. Do that a few thousand times, and your careful, circular orbit starts to wobble, then sag, then decay. In the early days of exploration, spacecraft sent to circle the moon kept drifting off course, dropping lower than they were told to, and nobody knew why until we understood the ground itself was pulling unevenly. It turns out a low orbit around the moon is one of the most unstable places you can put a machine. Most orbits eventually get yanked into the surface. Only a rare handful of special paths threaded carefully between the lumps survive for long. Every satellite we fly at the moon today has to account for gravity that behaves like a rigged table. So where did the lumps come from? Same origin as almost every scar up there. Impacts. When a massive asteroid hit the young moon, it punched down and the hot, dense mantle underneath rebounded upward, welling up into the crust and freezing there. A bullseye of heavy rock right under the target. The bigger and older the sea, the meaner the mascon. And this is why the word concerned isn't dramatic. The moon is where humans are going next. We're planning stations, fuel depots, satellites in permanent lunar orbit. All of it has to survive a gravity field that actively fights to pull hardware down. Get the math even slightly wrong, and the moon collects your spacecraft. It's a strange kind of danger. No explosion, no radiation, no cold. Just an ordinary gray plane, and buried beneath it, a hand you can't see, patiently pulling everything down toward the dust. Which is fitting. Because the next mystery is what happens when something finally hits. Number 4. The moon rings like a bell. We hit the moon on purpose. More than once. And what happened next has never fully stopped bothering people. During the Apollo missions, astronauts left seismometers on the surface, little machines that feel the ground shake. Then, on the way home, NASA took the spent rocket stages they no longer needed and deliberately crashed them into the moon, hard, just to see what the seismometers would feel. It should have been simple. A thud, a jolt, a tremor that fades in a few seconds the way it would on Earth. Instead, the moon rang. The shaking didn't stop. It built and rolled and kept going for minutes. For a full hour in some cases. The ground vibrated on and on like a struck bell that refuses to go quiet. One of the scientists watching the readout said the moon rang like a bell, and the phrase stuck. Because that's exactly what the data looked like. A single hit and an hour of ringing. Now, you've maybe heard a spooky version of this, that the ringing means the moon is hollow. It isn't. The real answer is stranger and more beautiful than hollow. On Earth, when the ground shakes, the energy dies fast. Our rocks are full of water, warm, cracked, alive. Water soaks up vibration like a sponge, soaks up sound. A quake here loses its energy in seconds and goes still. But the moon is the opposite of Earth in every way that matters here. It's bone dry. There's no water anywhere in the rock to absorb the shaking. It's cold, and it's a single unbroken shell with no shifting plates to swallow the energy. So when you hit it, the vibration has nowhere to go. It just bounces around inside, scattering through the dry stone, ringing and ringing until, an hour later, it finally, slowly, fades. Think about standing there when it happens. You'd hear nothing because there's no air to carry a sound. But under your boots, the entire world would be humming. A tremor with no noise running through 250,000 square miles of dead rock, lasting longer than your lunch. And notice what the ringing is telling us. The moon rings because it is perfectly, absolutely dry. No water to quiet it. Remember that. Hold on to it. Because the very next mystery is about the water the moon absolutely, impossibly should not have. Number 5. The radioactive near side. Look up at a full moon and you'll see the shape everyone sees. The dark patches, the man in the moon, the rabbit, Whatever your grandmother told you was up there. Those dark seas feel timeless and gentle. They're not. They're the fingerprint of a radioactive stain, and it only exists on the side pointed at you. Here's the split that breaks scientists' brains. The near side of the moon, the face we always see, is covered in dark, smooth, frozen lava seas. The far side, the hidden half, is almost none of that. It's pale, ancient, cratered highlands, and barely any of the dark seas at all. Two hemispheres of the same little world, and they look like completely different planets. Why? The answer is a mouthful, so scientists nicknamed it CREEP. It stands for the ingredients, potassium, rare earth elements, and phosphorus, and riding along with them, thorium and uranium, radioactive elements, the kind that generate heat as they slowly decay. And on the moon, nearly all of that radioactive material is concentrated in one blotch, on the near side, in a region under the largest dark sea. That one region covers only about 16% of the surface, but it holds something like 40% of the moon's heat-making radioactive elements. It is, in the most literal sense, a hotspot. A hemisphere-sized concentration of nuclear fuel baked into the crust. And that's the answer to the whole riddle of the moon's face. Radioactive elements make heat. Heat melts rock. So the near side, loaded with this stuff, ran hotter and softer for longer. It melted and welled up and flooded itself with dark lava that froze into the seas you see tonight. The far side, missing almost all of it, stayed cold and pale and blank. So the friendly man in the moon, the face that's watched over every human who ever lived, is not a face at all. It's a burn. A radioactive scar, pooled onto exactly one side, that turned half the moon dark while the other half stayed frozen. And nobody is fully sure why the radioactive material collected on that side and not the other. The moon should have mixed more evenly. It didn't. It went lopsided, dumped its nuclear heat onto one cheek, and stayed that way. You've been looking at the hot side your whole life, and that lopsided heat is about to move something enormous. Number 6. The wet moon paradox. 2 mysteries ago, the moon rang like a bell because it's the driest object you can imagine. Hold that thought while I tell you the opposite is also true. The moon has water. Water it has no business keeping. And that contradiction is one of the strangest things in lunar science. Start with how the moon was born. The leading story is violence. A planet-sized object slammed into the young Earth and the debris blasted off, molten and glowing, eventually clumping together into the moon. That whole process was hotter than anything you can picture. Any water, any delicate volatile chemistry should have boiled off into space and been gone forever. A moon, born in that fire, should be perfectly, permanently dry. Then astronauts brought home the glass. In the Apollo samples were tiny beads of volcanic glass, orange and green, sprayed out of ancient lunar eruptions and frozen mid-flight. And when scientists finally looked deep inside those beads, decades later, they found water. Locked in the glass, which means the water came from deep inside the moon, from a mantle that is far wetter than a dry-born moon should have any right to be. It got stranger in 2020. A NASA telescope flying high in the sky called SOFIA stared at the sunlit surface of the moon, the bright part, the part baked all day by the sun, and found water molecules sitting right there. Not hidden in a shadow. Not frozen at a pole. Out in the open, in the sunshine, where the textbook says water can't survive. So now there are 2 impossible waters, water buried deep in the interior, older than the seas, and water clinging to the sunlit dust, out where it should have cooked off long ago. A world that was supposedly born in fire and scrubbed dry keeps quietly handing us water everywhere we look. Nobody has fully explained it. Maybe the moon held on to some of its birth water despite the heat. Maybe the sun's own wind is planting it, atom by atom. Maybe comets and meteorites keep restocking it. The honest answer is that we know the water is real and we can't fully account for how it stayed. And this matters more than curiosity. Water on the moon is the difference between visiting and staying. It's drinking water, breathable oxygen, rocket fuel. The whole future of humans up there depends on water that, by every rule we know, should not be there. The moon keeps breaking its own rules, and the next rule it breaks is that it's supposed to be dead. Number 7. The heat. It shouldn't still have. Small things cool down fast. That's just how it works. A cup of coffee goes cold before a bathtub does, and the moon, in the great scheme of worlds, is small. It's had 4.5 billion years to sit in the freezing dark of space and lose every scrap of warmth it was born with. By now, it should be cold all the way through, a dead frozen rock. Except when we actually measured it, the moon was warmer inside than it should be. On Apollo 15 and Apollo 17, back in 1971 and 1972, astronauts did something that sounds boring and turned out to be haunting. They drilled into the moon and pushed heat sensors down into the ground. The idea was simple. Measure how much warmth is leaking out of the interior, and you can figure out how alive the inside still is. The readings came back too high. More heat was flowing up out of the moon than a small, ancient, supposedly dead body should still be producing. The interior wasn't as cold as it was supposed to be. Something down there was still generating warmth, billions of years after the moon should have gone stone cold. Part of that traces back to the radioactive hotspot from earlier. Both Apollo landing sites happened to sit near the edge of that creep region, that near-side stash of thorium and uranium, and radioactive decay makes heat. So some of the extra warmth is those elements slowly cooking. But that also means our only real measurements of the moon's inner heat were taken right next to the one spot guaranteed to run hot. And we still don't have a clean reading of what the rest of the moon is doing. So here's where it leaves us. We took the moon's temperature exactly twice in 2 spots over 50 years ago, and both times it felt warmer inside than a dead world should. We have never measured it anywhere else. The real heat budget of the moon, how alive its interior actually is still an open question resting on 2 old holes drilled into one radioactive corner. The word dead is doing a lot of lying. The moon is old and quiet and still. But somewhere under the crust, it's still holding heat it should have surrendered ages ago, and if the moon still has heat that deep, you have to ask, what's keeping it warm? The answer is beating at the very center. Number 8, the heart that never froze. Go all the way down. Past the rust, past the dry ringing crust, past the buried heat, to the very center of the moon. There should be nothing interesting there. A small world's core is supposed to freeze solid early and stay that way. A cold, dead ball of metal at the heart of a cold, dead rock. That's not what's down there. The proof came from the same Apollo seismometers that made the moon ring. For decades, that old data just sat in archives. Then, in 2011, a NASA scientist named Renee Weber and her team went back to those ancient recordings and ran them through modern processing, listening for the faint echoes that pass through the deepest parts of the moon. And in the echoes, they found the shape of the core. The moon has a solid inner core, like a small metal seed. But wrapped around it is a fluid outer core, liquid metal. And around that, a layer that's partly melted, still soft. Put together, the core of the moon is something like 60% liquid by volume. The inner solid part is only about 240 kilometers across, a little metal heart floating in molten metal buried at the center of a world we call dead. Sit with how wrong that is. This is a body 4 times smaller across than the Earth. It's ancient. It's had all the time in the universe to freeze. A core that small in a world that old should be solid straight through, cold and locked and finished. Instead, there's still liquid metal moving down there. The moon has a molten heart it should have lost billions of years ago. And nobody is fully sure what keeps it warm. Maybe it's the last radioactive dregs still decaying, still cooking. Maybe it's the Earth, flexing the moon with tides, kneading it just enough to keep the center soft. Maybe it's simply leftover heat from birth that a small world somehow refused to let go of. The models argue. The certainty isn't there. But the picture is unforgettable. When you look up at the calm gray disk, you're looking at a shell around a secret. Under all that stillness, at the exact center, there is metal that never froze. A slow, warm, liquid heart turning in the dark, keeping the moon just a little more alive than it has any right to be. A living heart moves things. And it turns out it moved the entire moon. Number 9. The poles that wandered. The moon's north pole is not where it used to be, neither is the south. At some point in the deep past, the entire moon rolled over in space, and we can prove it because the ice remembers. Here's how you catch a world tipping over. At the moon's poles, hidden in craters that never see sunlight, there's ancient ice. Frozen, protected, sitting in permanent shadow and permanent cold. That ice should be centered exactly on the poles, because the poles are the coldest, darkest place. But when scientists mapped it out, the ice was off. Shifted. Sitting slightly away from where the poles are today. And here's the detail that cracked the case open. The ice near the North Pole was offset in one direction, and the ice near the South Pole was offset in the exact opposite direction. That precise mirror image shift is the unmistakable signature of a world whose spin axis has physically moved. In 2016, a team led by a scientist named Matt Siegler read that pattern and realized the moon had wandered. Its axis had drifted about 6 degrees, roughly 125 miles, over about 1 billion years. And you already met the culprit. It's that radioactive hotspot, that near-side region loaded with heat-making elements. All that warmth made the region lighter, less dense, puffed up from the inside. And when you change how a spinning body's weight is distributed, the body slowly reorients itself, rolling until the balance settles. The moon's own hotspot threw off its balance, and the whole world turned to compensate, dragging its poles to new addresses over 1 billion years. Now feel the beautiful part. For that ice to still be sitting in the old spot, the ice has to be older than the wandering, which means those frozen deposits in the shadows are ancient beyond ancient, laid down before the moon rolled over, and untouched ever since. Scientists think that ice may be a time capsule, chemically linked to the very same water that filled the young Earth's oceans, a frozen record of where the poles used to be, and maybe of where our own water came from. So the moon isn't just strange on the surface, it is physically rolled through space, tipped by its own lopsided heat, and left its ancient ice behind, like a bookmark in the old position. The moon has changed where it points, and in the last mystery, it changes where it is. Number 10. The moon is leaving. Every night the moon is a little farther away than the night before. It is leaving, slowly, quietly, permanently. And the strangest part is that the number doesn't add up. We know it's leaving because of the mirrors. The Apollo astronauts left reflectors on the surface, and for over 50 years we've been firing lasers at them and timing the bounce, measuring the distance to the moon down to fractions of an inch. The answer is always the same. The moon backs away from Earth by about 3.8 centimeters every year, roughly the speed your fingernails grow. Over your whole life, the moon retreats about 3 meters and takes a tiny piece of Earth's spin with it, quietly lengthening our days. That sounds gentle. Here's where it turns into a real problem. Take that rate, 3.8 centimeters a year, and run the clock backward. Rewind it. If the moon has always pulled away this fast, then only about 1.5 billion years ago, the moon would have been sitting right on top of the Earth, touching it. But the moon is 4.5 billion years old. We've dated the rocks. Those two numbers flatly contradict each other. At today's speed, the moon is somehow far too close to be as old as it is, so the rate can't have been constant. And the answer scientists have landed on is quietly eerie. It's not the moon that's weird, it's this exact moment in Earth's history. Right now, our continents happen to be arranged so that the oceans slosh and drag against the seafloor unusually hard, and that drag is what flings the moon outward. Today's tides are abnormally strong. In the deep past, the moon crept away much more slowly, maybe a third as fast. We are simply living through a rare, fast chapter of the moon's long goodbye, and this is where the whole tour stops being a list of oddities and becomes something else. Because everything you've heard tonight, the rust, the buried metal, the ringing, the radioactive face, the water it shouldn't have, the heart that never froze, all of it belongs to a moon that is right now on its way out the door. One day, far from now, it will drift too far to ever cover the sun again. And the total eclipse, that perfect moment when the disk fits exactly over the star, will end forever. Nobody will ever see it again. The moon has spent 4.5 billion years being stranger than you were ever told, and it's spending every one of those years easing toward the exit. You just never noticed it was already walking away.